Next one. Another question, sir. Basic foundation based problems are over. What we did is we spent a lot of time understanding the definition of a prime number. Now we will see some questions. This is a previous year CAT question also, a basic question. Question is P1 into P2 into P3 and so on up to P7. It is equivalent to 510, 510. P1 into P2 into P3 and so on up to P7 is 510, 510. P1 is less than, P2 is less than P3 and so on up to it is less than P7. Okay. P1 less than, P2 less than, P3 and so on up to less than P7. What are all these numbers? All these numbers are prime numbers. So he is saying 7 prime numbers product is given as 510, 510. What is the value of the lowest prime number? That is P1. So there are 7 prime numbers whose product is 510, 510. What is the lowest prime number? The root cause of this problem is 510, 510, it is an even number. 510, 510, it is an even number. Suppose if I take all the 7 prime numbers as odd, P1, P2, P3 and so on up to P7. If I take all the 7 numbers as odd numbers, if I take all the 7 numbers as an odd number, odd into, what will be the product? Odd into, odd into, odd into, like that 7 numbers, 7 prime numbers which are odd, odd into, odd into, odd into, odd into, odd. 7 prime numbers product will be an odd number. But what is the right hand side? Right hand side is an even number. 7 numbers. If all the numbers are odd, product is an odd number, but I require an even number. That means all the 7 numbers cannot be odd. All the 7 numbers cannot be odd. Because the right hand side is an even number and there is only one even prime number, the only possibility is P1, it is 2 which is even. There cannot be 2 even numbers which are prime. All are distinct prime numbers. There is only one even number which is a prime number, that is P12. So P1 is 2. P1 it is 2. What is the, so one among them has to be an even number. What is the smallest prime number and even number? P1 will be equivalent to 2. All the 7 cannot be odd. Odd into odd into odd, it will be an odd number. 7 cannot be odd. What is the next case? 1 has to be even. If 1 has to be even, he is referring to P1 which is smallest. What is the smallest prime number and even? Answer for this question is P1 equivalent to 2. Answer for this question is P1 equivalent to 2. I hope the idea it is clear. The root cause of this problem is right hand side, it is an even number. In case if you want to know what are that numbers, which I will tell you once I discuss the divisibility rule of 7, 11, 13. 2 into 3 into 7 into 11 into 13 into 17. These 510, 510. In case if you want to know the numbers, the lowest prime number value it is 2. Sir, how to determine? I will park it for some time. Once I discuss the divisibility rule for 7, 11, 13, then I will come back to this question. 510, 510, it is an even number. What is the smallest number which is 2? Because it is an even number, one number has to be an even number. Original CAT question it is. Next one, P1 plus P2 plus P3 and so on up to P7. Please write down P1 plus P2 plus P3 plus P4 plus P5 plus P6 plus P7. It is equivalent to 1, 2, 3, 4, 5, 6. Read the question first. P1 less than, P2 less than, P3 and so on up to less than P7. Smallest number it is P1. That is the meaning of these inequality. P1, P2, P3 all are prime numbers. All these values which are given in the question, P1, P2, P3 till P7, all are prime numbers. Assume all are odd numbers. Assume P1, P2, P3 and so on up to P7, all are odd numbers. If I take all as odd numbers, let us see what is the left hand side nature. P1 it is an odd number, P2 it is an odd number, P3 it is an odd number, P4 it is an odd number, P5 it is an odd number, P6 odd number, and P7 also it is an odd number. P7 also odd number. What is odd plus odd? Even. What is odd plus odd? Even. What is odd plus odd? Even plus odd. Even plus even, it is an even number. Plus even, it is an even number. Even plus odd, it is an odd number. It is an odd number. But the right hand side, 1, 2, 3, 4, 5, 6, it is an even number. That means my assumption that all the 7 prime numbers should be odd, it is incorrect. My assumption that all the 7 prime numbers, they are odd, it is incorrect. Odd, 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 7 prime numbers, odd, odd, odd. Odd number of odd numbers, sum will be an odd number. But the right hand side, this is an even number. The root cause of this problem is, right hand side, it is an even number. That means all the 7 cannot be odd. 1 has to be even. Now, I am referring to P1. What is P1? P1, it is the smallest number. What is the smallest prime number? What is the smallest prime number? Which is even. Which is even. Answer has to be 2. Answer has to be 2. No, it cannot have P2 as 2 because there is no prime number less than 2 which is smallest. I hope it is clear. It cannot be given, sir. Can one of the number has to be even? Can't I give P7 as 2? You cannot give because there any number less than 2, it cannot be a prime number. Smallest prime number which is even. That is the importance of this question. Otherwise, probably we would have given 2 to some other value. There cannot be any other prime numbers less than 2. The lowest prime number it is 2. The lowest prime number it is 2. It is also a cat replica question. Beautiful question. There is no value. There are variables given. Right hand side is an even number. So I assumed that all the numbers are odd numbers. P1 to P7, total 7 odd numbers are there. Odd number of odd numbers, if I add, I will get an odd number. I will get an odd number. Right hand side is an even number. So therefore, all the 7 numbers cannot be odd. 1 has to be even. I hope this idea it is clear. Again a cat replica question. Beautiful question, sir. P equivalent to 51 factorial plus 1. P equivalent to 51 factorial plus 1. How many elements are there in the set? There is a set that is present. P plus 1, P plus 2, P plus 3 and so on up to P plus 50. How many elements in this set are prime numbers? How many elements in this set are prime number? First thing we have to notice 51 factorial. What is the definition of a factorial? From the number that is given, write down the product of all natural numbers from n to 1. 50 factorial is 51 into 50 into 49 and so on up to 3 into 2 into 1 and so on up to 3 into 2 into 1. Very, very important. See here. P plus 1, it is 51 factorial plus 1 plus 1, 2. 51 factorial plus 1 plus 2 plus 3. 51 factorial plus 1 plus 3 plus 4. 51 factorial 1 plus 50, 51. 1 plus 50, 51. Now see here. 51 factorial plus 2, 51 factorial plus 3, 51 factorial plus 4, 51 factorial plus 50. Listen carefully, sir. 51 factorial. Observe here. Any number multiplied by 2, it is an even number. 51 factorial, it is an even number. 51 is an odd number. 51 factorial. 51 factorial is the product of all the natural numbers from n to 1. 51 factorial is 51, 50, 49 and so on up to 3 into 2 into 1. 51 factorial even number. 2 is an even number. Even plus even is even. Is there any even number greater than 2 which is a prime number? No. P plus 1, it is out. Again I am explaining. 51 factorial plus 1 plus 1. 51 factorial plus 2. 51 factorial, it is divisible by 2. Because 2 into any number. 2 is an even number. Even plus even is even number. Is there any even number greater than 2 which is a prime? Not possible. Next one, 51 factorial. 51 factorial contains 3. 3 into any number. 3 into any number. These divisible by 3. 3 into any number. It is divisible by 3. Plus 3. These also divisible by 3. Plus 3, it is also divisible by 3. 51 factorial, it is divisible by 3. 3, it is divisible by 3. Answer should be divisible by 3. Any number divisible by 3, it will be a multiple of 3, thereby it is a composite number. Not possible. 51 factorial, even. 4 is an even number. Even plus even, it is an even number. Even number greater than 2. Not possible. 51 factorial, even number. 50, it is an even number. Answer is an even number. Is there any even number greater than 2 which is a prime number? No, not possible. Idea behind this question is all the numbers which we are adding to 51 factorial, they are all a part of this number. Yes or no? 51 factorial is 51 into 50 into 49 and so on up to 3 into 2 into 1. So all these numbers are a part of the number. None of the numbers it is a prime number. How many elements are prime numbers? No element it is a prime number. No element in the set it is a prime number. No element in the set is a prime number. No element in the set it is a prime number. Is the idea clear? Again I am explaining. P is 51 factorial plus 1. P plus 1. 51 factorial plus 2. 51 factorial even number. 2 even number. Even plus even is an even number. Other than 2, there is no even number which is prime. Even prime. Out. 51 factorial divisible by 3. Plus 3. Answer should be divisible by 3. Not possible. Even number, even number. Answer is an even number. 2, 3, 4 till 50 are a part of 51 factorial. Put a star mark on this question. No element in the set, it is a prime number. No element in the set, it is a prime number. Another cat level question, sir. Another cat level question. These one more 9 is missing. Or you remove one more 9 here. Or keep it as it is. You can change the question as per. Here it is 1 followed by 999, right? So one more 9 it is extra. Now you can solve these cat replica question. Cat exam question. Easily you can solve, otherwise you will think that this question is a difficult question. Number of prime numbers P is such that P lies from 1,999 factorial plus 1 less than 1,999 factorial plus 1,999. 1,999 factorial plus 1,999. Now see here. Natural number we want. So what will be the next number? Next number will be 1,999 factorial plus 2. Next number will be 1,999 factorial plus 3. The last number, the natural numbers, they will go with a difference of 1 plus 1998. The P can take any value from this one. I hope it is clear. Natural number difference will be 1. 2, 3, 4, 5, 6 and so on. Difference will be 1. 1,999 factorial plus 2 plus 3 and so on up to plus 1998. Just because we solved the previous question, now the logic will become very easy. 1,999 factorial is 1,999 into 1,998 and so on up to 3 into 2 into 1 and so on up to 3 into 2 into 1. Now listen carefully. 3 into 2 into 1. Now you can solve it. This is an even number. Plus, I will use a different color. Even number, even number. Even plus even is even. There is no even number other than 2, which is a prime number. This is divisible by 3. Why? Because 1,999 factorial contains 3. 3 is divisible by 3. Answer will be divisible by 3. Even number plus even number. Answer will be an even number. If you know this logic, a CAT question can be solved in less than 20 to 30 seconds. Answer for this question is how many prime numbers are there? None of the prime numbers exist. Why? Because after plus whatever you are adding 2, 3, 4, 5 till 1,998 are actually a part of this number. 1,999 factorial. It is divisible by 2, even number, divisible by 3, divisible by 4, divisible by 5, and it is divisible by 1,999. Very, very good question. Very, very good question. I hope the idea it is clear. Once you listen to all the classes, you will see a tremendous improvement in the mock scores. Mock scores increasing will give you a confidence, and thereby you will start feeling the way you prepared for your +1 and +2 under the guidance of great teachers. You are extremely confident of clearing the examination. My role is to give you that confidence by sharing as many problems as possible from a particular topic by investing more and more time. Answer is 0. I hope the idea it is clear. The same question can also be asked like this. Please read the question first. Read the question first. N is equivalent to P plus X. N is equivalent to P plus X. P is the product of all prime numbers till 31. P is the product of all prime numbers 2, 3, 5, 7 and so on up to 31. P is the product of all prime numbers till 31 plus X. X is a natural number. Okay. X is lying in the range. What is the range? 2 to 29. X can take 2, X can take 3, X can take 4, X can take 5, X can take till 29. I understood the question and I translated the question into an mathematical expression. N equivalent to P plus X. P is the product of all prime numbers less than or equivalent to 31. The lowest prime number it is 2. 2, 3, 5, 7 till 31. X is a natural number which can take any value from 2 to 29. X can take any value from 2 to 29. For how many values of X? What all values of X will take such that N is a prime number. Such that N is a prime number. Listen carefully, sir. Such that N is a prime number. The first thing, this is 2 into any number. 2 into any number. It is an even number. If I take 2, 2 is an even number. Even plus even. It is 2. Is there any even number greater than 2 which is a prime number? Not possible. 2 it cannot take. Again I am explaining. 2 into any number even. 2 is an even number. Even plus even, it is an even number. Any number multiplied by 3, it is divisible by 3. These is also divisible by 3. These is also divisible by 3. If I add two numbers which are divisible by 3, answer should be divisible by 3. Answer should be divisible by 3. Any number divisible by 3, it becomes a multiple of 3. It becomes a multiple of 3. If it is a multiple of 3, it is a composite number. 2 into any number, even. 4 is an even number. Even plus even, it will be an even number. Are you all with me? 5. This number multiplied by 5, it is a multiple of 5 plus 5. Answer will be a multiple of 5. Answer will be a multiple of 5. This is contains 29 and these 29. 29 divisible by 29. 29 into any number divisible by 29. If I add two numbers which are divisible by 29, answer will be divisible by 29. Answer will be divisible by 29. Is there any number other than 29 which is a multiple of 29 and a prime number? No. Answer is no value of x. Answer is no value of x exists such that for that value of x, n is prime. N equivalent to p plus x. P is the product of all prime numbers 2 to 31. Now if you see x value, the numbers which I wrote are actually the numbers which are derived from the elements of p. 3 is, x is a part of p. 4 is derived from 2. 4 is derived from 2. 6 is derived from 2 and 3. If I take 2, even plus even, answer will be divisible by 2. So no prime number exists. Divisible by 3 plus divisible by 3. Even plus 4 is also an even number. 5. Divisible by 5 plus 5. 5 is also divisible by 5. Answer will be divisible by 5. I hope the idea it is crystal clear. Idea clear? Next one. Another good question, sir. Next 3 questions. Listen carefully. P plus 2, P plus 4 are prime numbers. There are triplets given. The values of P we need to find it out such that these triplet becomes a prime number. How many prime values P can take? Again a cat replica question. Cat replica question. Now see here. Cat replica question. Listen carefully, sir. What is the concept we discussed? Concept. Every prime number greater than 3, it is of the form 6k plus or minus 1. We will use this concept. Every prime number greater than 3, it will be of the form 6k plus or minus 1. This will help us to solve this question. So there is a triplet that is given. P plus 2, P plus 4. P plus 2, P plus 4. The lowest prime number, it is 2. So if I take 2, 2 plus 2, 4, 2 plus 4, 6. 4 and 6 are not prime values, eliminated. If I take 3, 3 plus 2, 5, 3 plus 4, 7. 3, 5 and 7. All are all are prime number values. 3, 5 and 7. 3, 5 and 7. Any prime number greater than 3. It is of the form 6k minus 1 or 6k plus 1. 6k minus 1 plus 2. 6k plus 1. And it is 6k minus 1 plus 4. 6k plus 3. 6k plus 3. Now listen carefully. 6k, it is divisible by 3. And these also divisible by 3. These also divisible by 3. So answer, one value will be divisible by 3. All the 3 should be prime numbers. 6k minus 1 out. If I take 6k plus 1. These 6k plus 1 plus 2. 6k plus 3. And 6k plus 5. 6k plus 3. 6k plus 3. It is also divisible by 3. That means there exists no prime numbers greater than 3 which are of the form 6k minus 1 or 6k plus 1. If I am taking 6k minus 1, one number is becoming 6k plus 3. 6k is divisible by 3. Plus 3, it is also divisible by 3. 6k plus 1 plus 2, one number is becoming divisible by 3. If a number is divisible by 3, then it will become a composite number. How many prime values P can take? Number of prime values P takes, it is 1. Number of prime values P takes, it is equivalent to 1. And the value of P is 3. And the value of P is 3. Idea clear? Number of prime values P takes, it is 1. And the prime value, it is 3. Crystal clear idea? P plus 2, P plus 4. P plus 2, P plus 4. P is 2. 2 plus 2, 4. 2 plus 4, 6. The concept which we used. Any prime number greater than 3, it is of the form 6k plus or minus 1. Any prime number greater than 3, it is of the form 6k plus or minus 1. Idea clear? Very clear idea. Another question. Another one. There is a cat similar question which came, that also we will solve. P plus 14. P plus 14. P plus 26 are prime numbers. P plus 14, P plus 26 are prime numbers. How many prime values? How many prime values P takes? How many prime values P takes? This question and the above question, both are similar model. Both the questions we will solve. Both the questions we will solve. P plus 14, P plus 26 are prime numbers. How many prime values P takes? P plus 14 and P plus 26. P plus 14, P plus 26 are prime numbers. How many prime values P can take? What is the concept that we are using? Any prime number greater than 3. Any prime number greater than 3. It is of the form 6k plus or minus 1. Any prime number greater than 3, it is of the form 6k plus or minus 1. I hope the idea it is clear. So if a prime number, it is 2. 2 plus 14, 16. 2 plus 26, 28. 16 and 28. 16 and 28 are even numbers? Not possible. There is no prime number other than 2 which is an even number. If it is 3. 3 plus 14, 17. 3 plus 26, 29. 3, 17 and 29. All the three are prime numbers. All the three are prime numbers. One value we got, P equivalent to 3. Suppose if I take 6k plus 1, 6k plus 15, 6k plus 27, 6k plus 15, divisible by 3, divisible by 3. Answer will be divisible by 3. This case not possible. This case not possible. 6k minus 1, 6k minus 1 plus 14, 6k plus 13. It is 6 into k plus 2 plus 1. These 6k plus 25, 6 into k plus 4 plus 1. K plus 4 plus 1. K plus 2 you can give it as some variable A. 6A plus 1 and 6B plus 1. For me what is important is 6K minus 1. K plus 2 I am calling it as A. K plus 4 I am calling it as B. Oh, there are, I got a series like this. 6K minus 1. 6k minus 1, 6a plus 1, 6b plus 1. Let us take some prime numbers which are of the form 6k minus 1. Let us check whether it is giving you the answer. Suppose if I take 17. 17. Is 17 of the form 6 into 3 minus 1? Yes. 17 plus 14, 31. Yes. 17 plus 26. 43. 17, 31 and 43. All these three are prime numbers? Definitely yes. Let me take another prime number, 83. 83 it is 6 into 14 minus 1. 83 plus 14, 97. 83 plus 26, 109. It is also a prime number. That means I just took two samples which are of the form 6k minus 1. There could be some more. We do not know. In 2-digit numbers there are some prime numbers. In 3-digit numbers there are some prime numbers. 4 digits there is no restriction on P. So P can take a 2-digit numbers which are of the form 6k minus 1 which will satisfy. 3-digit also some might satisfy. 4-digit also some might satisfy. So answer for this question is infinite. We do not know. There could be more numbers. In 2 digits only I got 2 numbers. 3 digits there could be some numbers. There could be some numbers. I hope the idea it is clear, right? So 2 digits, 3 digits, 4 digits. It is infinite, which we call it as, since there is no upper limit on P, countably infinite. We just did it for a 2-digit number, I got some numbers. 3 digits, there could be some numbers. 4 digits, there could be some numbers. 5 digits, there could be some numbers. 6 digits, there could be some numbers. So answer is infinite. Answer for this question is infinite. Idea clear? Next one. Above, one more question. P plus 12. P plus 12 and P plus 4. P plus 12, P plus 4 are prime numbers. P plus 12, P plus 4 are prime numbers. How many prime numbers P can take? How many prime numbers P can take? If P takes 2, 2 plus 12 is 14. 2 plus 4 is 6. 14, 6 and 2. 14, 6, they are all even numbers. Other than 2, there is no even number which is a prime number. So if it is 3, 3 plus 12, 15. 3 plus 4, 7. It is not possible. Any prime number greater than 3, it is of the form 6k minus 1 or 6k plus 1. 6k minus 1 plus 12. 6k plus 11. 6k minus 1 plus 4. 6k plus 3. 6k plus 3. 6k divisible by 3. 3 is also divisible by 3. 6k plus 1 plus 12. 6k plus 13, which is 6 into k plus 2 plus 1, which is 6a plus 1. 6k plus 5. 6k plus 1. This can be written as 6 into k plus 1 minus 1. 6b minus 1. 6b minus 1. That means it is indicating that there could be some values which are of the form 6k plus 1, which might result in a prime number. Which might result in a prime number. Let me take 19. 19 is 6 into 3 plus 1. 19 plus 12, 31. 19 plus 4, 23. 19 plus 4, 23. Suppose, for example, if I take some other number, you can take 19, 31, 21. Suppose if I take 43. 43 is making 55. Suppose if I take 40, it should be a prime number, right? 6 tens are 61. 61 it is making. Suppose if I take 11, 67. If I take 67, 6 into 11 plus 1, 67 plus 2, 79, 67 plus 4, 71. So in a 2 digits only, I got 2 numbers. Similarly, 3 digits, 4 digits, 5 digits, there could be any number. Same answer. Answer is countably infinite. Answer is countably infinite. You can count it, but you have better things to do in life. You can count it, but you have better things to do in life. These 3 questions, I hope it is clear. Cat question, cat replica question. Previous it is a cat question. Each and every model in detail I am going to discuss. P plus 12, P plus 4. P plus 12, P plus 4. Idea clear? These 2 questions.